This is a video on the domain and range. The question states, describe the domain and range of the function f of xy is equal to the square root of 9 minus x squared minus y squared. So let's start with the domain. To find the domain, we want to find out all values of x, y, such that if we plug in x and y, we get a defined function value. So the only obstacle to evaluating this function is the square root. And that's because a square root must be such that the inside of that square root has to be non-negative. So I can set the inside to be greater than or equal to 0. So I get 9 minus x squared minus y squared is greater than or equal to 0. So now let's add x squared plus y squared to both sides, and I get x squared plus y squared is less than or equal to 9. Well, this is just a disk of radius 3 centered at the origin. It's a disk because we have this less than or equal to, and the equal part tells us that we include the outer circle. So I sketch a picture. It's a circle of radius 3 centered at the origin, including the outer circle. So there's my domain. Notice that if it had been a greater than or equal to instead of a less than or equal to, we would include all the stuff outside of the disk and none of the stuff inside of the disk. But we have a less than or equal to, so we have the disk. So now let's find the range. The range is going to be all the numbers we get by plugging in x's and y's. So first we have a square root, and square roots produce only non-negative values. So in particular, notice if x is 3, for example, and y is 0, then we get 9 minus 9, which is 0, and the square root of 0 is 0. So the range is going to start at 0, and the very largest the range is going to get is when x and y are both equal to 0, because taking away 0 from 9 will be the very biggest thing we can get. And when we do that, we get the square root of 9, which is just 3. So we can conclude that the range is a set of all values z. We typically use the letter z to indicate the dependent variable. So we have the set of all z such that z is between 0 and 3, including the endpoints. So now let's state our final conclusion. We can say the domain is the disk of radius 3 centered at the origin, including the outer circle, and the range is a set of all values of z between 0 and 3, including the endpoints. And I'm done with the problem.